Hi, Mr. Wright here, and welcome to this film in which I'll work through 6 IGCSE questions on bounds. Now, you can download the questions by clicking the link in the description, and then you can work through the questions before you watch the film, or you can work through the questions as you watch the film and work alongside me. Now, these are all pretty feisty questions, grades 7, 8, and 9, and the last one especially is a definite grade 9 brutal question. If you find this film useful, please hit like, please leave me a comment and tell me so. If you've got any questions, leave them in the comments and of course I'll respond. Now, before we make a start, as you watch the film, you'll see that I use a set routine when I answer questions involving bounds. This is because my routine means that I only concentrate on one thing at a time, so I'm less likely to make a mistake. And my routine also means that I lay out each stage of my working. So should I make a mistake, the examiner will be as generous as they possibly can with part and method marks. Right, let's get on with the maths. Question 1. Right, now the first thing I'm going to do is to ignore all of this. And I'm simply going to write down the lower and the upper bound of each of my variables. So x equals 8 to one significant figure. So that's going to be an upper bound of 8.5 and a lower bound of 7.5. A is 4.6 to two significant figures, 4.65, 4.55. And m is 20 to the nearest 10. So half 10 is 5. So I'm going 5 up and 5 down. Now I'm going to pay some attention to this. In fact, I'm going to copy it down. P equals A over m minus x. And only now am I looking at this, the lower bound of P. So I want the lowest possible P. So now I'm thinking about which A I want, which M and which X. And I'm going to write down my upper and lower bound arrows here. So if I want the lowest possible P, I want the lowest possible A, and I want the denominator to be as high as possible. Because if you divide by a higher number, you end up with a lower answer. So how do I get the highest possible denominator? Well, I'm going to want the highest possible m and the lowest possible x. So the difference between those two numbers is as large as possible. And only now do I substitute in my numbers. So I'm going to want the lowest possible a, the highest m, and the lowest x. So I'm going to have 4.55 divided by 25 minus 7.5. And I'm going to put that into my calculator. Now I'm hoping I'm going to end up with a terminating decimal because the question doesn't ask me to give my answer to any particular degree of accuracy. And I do. I get 0.26. And so there is question 1, and you can see the different stages of my solution. Question 2. Now, question 2 is a different sort of bounds question. And in this question, I've got to work out the value of a to a suitable degree of accuracy. But we're not going to look at that yet. We're going to start this question in exactly the same way as we started the last one. So the first thing I'm going to do is I'm going to write down the upper and the lower bound of each of my variables. So V is 4523 to two decimal places. So that's 45235 and 45225. Meanwhile, U is 5.12 to two decimal places, 5.125, 5.5115. And T is 8.5 to two significant figures, 8.55, 8.45. It's so important that you write down those upper and lower bounds, because if I make a mistake with one of those, but then I carry through the correct bound, I don't want to lose any more marks than I need to. So show your thinking. Now, again, just like before, I'm going to write down the formula for A. And only now do things take a different turn, because this question here asks me to work out the value of A to a suitable degree of accuracy. So what I'm going to do is I'm going to work out the upper value of A, the upper bound of the value of A, and I'm also going to work out the lower bound of the value of A. And then we'll look at those and ask ourselves what we know about what A actually is equal to. So on the left here, in red, I'm working out the upper bound of A. So I'm going to want the highest V and the lowest U, so that the numerator is as high as possible, and I'm going to want the lowest possible T. So I'm dividing by a low number, so I get a larger answer. And on the right, the lowest bound of A, the lower bound, I'm going to want the lowest possible numerator. So I want the lowest V and the highest U. And because I want a low answer, I want to divide by the largest number I can. So now let's go ahead and find the upper bound of A. So it's the highest possible V, 45.235, minus the lowest possible U, divided by the lowest possible T. So what is that, by the way? Let's find out, shall we? 45.235 minus 5.112 all over 8.45 gives me 4.74828 4024. Great. Now let's work out the lower bound of A. So I'm going to have the lowest V, 45.225, minus the highest U, 5.125, all divided by the highest possible T, 8.55. Let's work out what that is. 45.225 minus 5.125 all over 8.55 gives me 4.69005848. Now, in this question, I'm asked to work out the value of A to a suitable degree of accuracy. So you know that A lies between the lower bound and the upper bound. You know it lies between 4.69005848 and 4.7482844024. So can you, for instance, say that A is equal to 4? Well, if you were giving A to the nearest whole number, the upper bound would suggest that it was 5, and the lower bound would suggest that it was 5. So you could definitely say that A is 5 to the nearest whole number, for sure, because whatever A is, and remember A lies between our two long decimals there, whatever it is, it's definitely 5 to the nearest whole number. Could you round whatever A is to one decimal place? Well, if you look at the red number here, if I were to round that to one decimal place, then you say that A was 4.7. Great. What about the blue number? If you were to round this to one decimal place, it would be 4.7 as well. So whatever the true value of A is, and remember it lies between those two long decimals, whatever the true value is, it will be 4.7 to one decimal place. Great. What about if you round it to two decimal places, or three significant figures? Well, if it were the red, it would be 4.75, and if it were the blue, it would be 4.69, no. So whatever it is between the blue and the red, you can't say for sure what it would be to two decimal places. But you can say for sure that A is equal to 4.7 to 1 decimal place or 2 significant figures. And when it says work out the value of A to a suitable degree of accuracy, I have worked out that whatever A is, it is definitely 4.7 to 1 decimal place. And that is my solution to question 2. Question 3. Right, remember, we know it's a bounds question. Let's stick to our routine. Let's first of all write down the upper and the lower bounds of each of our variables. So x is 28.4 to 1 decimal place, so 28.45 or 28.35. Y is 17, correct to 2 significant figures, 17.5, 16.5. And W is 90, correct to the nearest 5, halve 5, 2.5, add it on, take it away. Right, now let's write down our formula for T. Okay, all I'm doing is copying it down. And now comes some thinking. Calculate the upper bound, So I'm going to want the numerator to be as high as possible, aren't I? So I'm going to want to take my highest possible x to square it and my highest possible y to square it. And if I want the value of t to be as large as possible, I want to divide by the smallest possible number. Okay, so I'm going to have the highest possible x to square it. So 28.45 squared plus the highest possible y, 17.5 squared, divided by the lowest possible w, 87.5. Now, I'm not expecting this to be a terminating decimal because I'm asked to give my answer correct to 3 significant figures. Use the function on my calculator, 28.45 squared plus 17.5 squared over 87.5 gives me 12.75031 and so on. So to 3 significant figures, 12.8. And that is question 3 done. Question 4. Right. In question 4, we're building a fence. But the moment that we realize it's a bounds question, we go to our normal routine. So the length of the fence, the total length of the fence is 50 meters. Correct to the nearest 5 meters. Halve the 5, 2.5. So an upper bound of 52.5 meters and a lower bound of 47.5 meters. The length of each fence panel, is 1.3 meters, correct to the nearest 10 centimeters. Let's go over here and have a think, shall we? Let's work in centimeters. 130 centimeters, yeah, 1.3 meters. Correct to the nearest 10. So halve the 10 and 5, add it on, take it away. Aha! So the 1.3 is going to be an upper bound of 1.35 meters and a lower bound of 1.25 meters. The cost of each fence panel is $8.65. Well, that just seems to be a fact. Look, there's no approximation there. That's exactly what each fence panel costs. Diego may only buy complete fence panels. Makes sense. He only pays the number of panels he needs to build the fence. Okay. Work out the greatest difference in the possible amounts that he could pay to build the fence. Well, I suppose we have to work out the most he could pay and the least he could pay. So let's do the least he could pay here. Least he could pay. And let's do the most he could pay. So if he's going to pay the least, then we want him to need the fewest possible number of fence panels. So the fewest possible number. So if we're going to do the fewest possible number, then we better have the shortest possible fence divided by the longest possible fence panel. So that's how many fence panels we need, isn't it? And then I guess we'd multiply that by 865. But let's just have a think about that, because I wonder if that's going to be a whole number of fence panels. So 47.5, the shortest possible fence, and let's assume that each panel is as long as it could be. So that means he's going to need 35.18. So let's just call that 36 panels, shall we? And he's going to pay 865 a panel. 36 times 8.65. So that means he's going to spend £311.40. So now let's go over to the right and let's work out the least he could pay. Sorry, the most he could pay, I beg your pardon. So we better have him needing as many fence panels as possible. So the number of let's have the longest possible fence, and let's have each fence panel to be as short as it possibly can be. That means he'd need that many fence panels, and then of course each panel cost $865. But we better be careful again, wouldn't we? Because we don't want to have part of a panel. Oh no, that's right, that's 42 panels. So that's 42 panels at $865 each. Gives me a total cost of £363.30. Now what's the question say? The greatest difference in the possible amount. So I'm going to do 363.30 minus 311.40, the greatest he could pay, subtract the least he could pay, gives me an answer of £51.90. And that is question 4 there. Question 5. A solid sphere has a radius of 2.8 centimeters correct to 1 decimal place. Wait a minute. Let's write down the bounds. Radius, 2.8 centimeters. Correct to 1 decimal place, 2.85, 2.75. The sphere has a mass of m pi grams where m equals 260 to correct to 2 significant figures. Wait a minute. So the mass is 260 pi grams, where the 260 is correct to 2 significant figures. So 265 pi would be the upper bound and 255 pi the lower bound. Work out the upper bound for the density of the sphere. Right, we better get that formula, hadn't we? Now the density of a sphere, let's have a look. Here's my formula triangle for density. So density is mass divided by volume. So let's write that, shall we? Density equals mass divided by volume. Okay, work out the upper bound for the density of the sphere. So we're going to want the upper bound of the density, which means we want the highest possible mass and the lowest possible volume. But wait a minute, I know the mass, but I don't know the volume. But I do know from the formula sheet that the volume of the sphere is 4/3 pi r cubed. So I can work out the lower bound of the volume, can't I? So the volume, the lower bound of the volume, will be 4/3 pi r cubed. We want the lower bound of the volume, so I'll use the lowest possible r. So the lower bound will be 4/3 pi times the lowest possible r, 2.75 cubed. So on my calculator, I'm going to work out 2.75 cubed, and then I'm going to multiply that by 4/3, which gives me 1331. Let's write that legibly. 1331 over 48 pi. Now I might just check that, just in case I press the wrong button. 4/3 times 2.75 cubed. And by the way, when you're doing your exam, there's absolutely no harm in checking something. And yes, I've got that right. So that's my lowest possible volume. So now let's go back here. Highest possible density, we said. So we said we wanted the highest possible mass to 4.65 pi over the lowest possible volume, 1331 over 48 pi. Okay, so pi's will cancel, won't they? So I can just do 265 divided by 1331 over 48. That gives me 9.556724, and so on. And we want this correct to 2 decimal places, 9.56. And there is my question 5 complete. I suppose we could just check that we're working in the right units, grams per cubic centimetres, and we are. Grams and cubic centimetres, centimetres for the radius, so cubic centimetres for the volume. Question 6. The diagram shows a triangle ABC. Look at this. We're given some values for C, X, and Y here. So let's work out the upper and the lower bounds without thinking about anything else. 11.5, correct to 1 decimal place. 11.55, 11.45. X is 80 to the nearest whole number, to the nearest 1, halve 1, a half, add it on, take it away. And Y is 75 to the nearest whole number. 75.5, 74.5. Okay, calculate the upper bound for the value of B. Well, I suppose first of all we have to think, how on earth do we find B? Well, I'm thinking if we know X and we know Y, then we can find this angle. And then once we've got that angle, because we also know C, by the way, once we've got that angle, the angle at B, then we can use the sine rule, because we'll have the angle and we're looking to get B, and we know the angle Y and we know the opposite angle C. Okay, now we're just going to have to be very careful because it's a little complicated. So let's take one thing at a time, shall we? Let's work out the angle B. Now it's going to have a lower bound and it's going to have an upper bound. Okay, the angle B upper is going to be 180. Take away the lowest possible values of X and the lowest possible value of Y. So that is going to be my upper value, the upper bound of the value of the size of angle B. Just making sure I don't press the wrong button on my calculator. It gives me 26. And what about angle B, the lower bound? Well, that will be 180 minus the highest possible X and the highest possible Y. So I'm thinking I know what that is, but I'll just go steady, put it into my calculator, gives me 24. Okay, now let's work out how I would go about finding B. So if I were finding B, I would go B over sine capital B equals C over sine capital C. And so my formula for B would be C over sine C times sine B. And we want the upper bound for B. So I would want the highest possible C and the lowest possible sine C, which would make this fraction as high as it could be. And then I would want to multiply that fraction by the largest possible sine of B. Okay, so now the highest possible C is 11.55. Now, the highest possible sine C, well, that, by the way, is the highest possible sine of y, because y is the angle at C. Right, so the highest possible sine y. Well, if you're not sure, you can try signing both of your alternatives for y, and then you'll know which is the largest. Okay? Or you might feel sufficiently at ease with your sine curve to know which you're going to use. I'm just going to make it really clear for you here. If I do sine of 74.5, then I get 0.96360304,532. And if I do sine of that higher angle, see what I'm going to get. Sine 75.5. Then I get 0.96814, and so on. And so, sine of the lower angle is less, and because I want the lowest possible of sine y, I'm going to have on the bottom here sine of the lowest angle, 74.5, times. Now, I want to multiply by the sine b, the highest possible sine b. So you could, of course, just make sure you can sine 26 and sine 24, unless you're absolutely certain, because you are absolutely certain about the shape of your sine curve. Sine 24, to make it clear, is 0.4673, and so on. And sine 26 is higher, 0.438, and so on. So I'm going to multiply by the sine of 26. And now I think I'm ready to work out the upper bound, the highest possible value of b, the upper bound of b. I'm going to go 11.55 over sine of 74.5, close the bracket, multiplied by sine of 26, close the bracket, equals. And I get 5.254, and so on. And it wants the answer to 3 significant figures. So that's going to be 5.25 to 3 significant figures. And that is my solution for number 6. Well done indeed for making it through to the end of those grade 7, 8 and 9 questions on bounds. I would think that some of those are definitely grade 9 material. Hit like if you found the film useful. If you've got a question or a comment, please do comment. I read every comment. I reply to all of them too, and it would be good to hear from you. Thanks for watching. See you in the next film.